morning, everyone. What a lovely morning we have in Denver today. Welcome to DevDay. We'll be talking about unlocking the future of EVM, specifically on Hedera EVM, for the next 25 minutes or so. I am Anurag Saksena. I have with me here Fernando Paris. We lovingly call him Fur. He has flown all the way from Spain just to be with us today. He is also Senior Director of Software Engineering at Hashgraph. He's been with us for a year and a half. And he also co-founded IO Builders. He's got wealth of experience in smart contracts, EVMs, everything to do with Web3. Fur?
Thank you, Anurag. I'm Fer, and have the pleasure to present today this talk with Anurag Saksena, which is our Director of Software Engineering. He has been with us 1 year and a half within Hashgraph. And before Hashgraph, he has been working on Amazon and mainly on AWS.
Thank you. We have a great agenda today. We'll be talking about 4 things. First, we'll start with what if building on EVM could be a truly awesome experience? The second topic would be anatomy of Hydro EVM. This is where we'll be spending bulk of our time. We'll talk a little bit about a new HIP that we have, which is built-in transaction scheduling. And we'll wind up with what is coming soon. And if we have time, we'll use that time for Q&A. Fur?
Richard introduced the concept of EVM compatibility. So as you remember, compatible means that you can run smart contracts, and being really equivalent is following the yellow paper. In our case, we are compatible, but what if building on the EVM could be truly awesome? That the protocol itself manages the heavy lifting and also has built-in features. In our case, we have high throughput, TPS, stable costs. We're also extending the EVM with built-in features like you can scale a smart contract in the future, and token services we will see around in this talk. Also, what if a performant EVM, which is performing rate, is feasible? And also, what if you can use the Ethereum community tools that you like with the experience you really want to have? No? That is what we are focusing on Hashgraph and Hedera, and it's our daily mission, and that's what we're looking for.
Okay, so let's talk about anatomy of Hydro EVM. I'll be using the term Hydro EVM and Hedera EVM interchangeably, so just don't get confused. For the purpose of this talk, they're both exactly the same thing. So what does Hydro EVM really has to offer? Okay, so these are the key offerings that we have, these 3 key offerings. Let's say you are a developer on Ethereum. You like to write program in Solidity. You can write your smart contract in Solidity and deploy it on Hedera exactly in the same way as you can deploy it on Ethereum. All you have to do is just, instead of pointing it to the Ethereum endpoint, you just point it to the Hedera RPC endpoint, and it'll be, and that's it. Secondly, you get the EVM compatibility with high throughput. Okay. What it means is that you can get the Ethereum developer experience, but you're not limited by the Ethereum's bottleneck on scalability. Our Hedera network can handle much higher volume of transactions with fast finality and with predictable fees. And thirdly, you get the interoperability with the Hedera services. If you're a Solidity programmer, you can write your contract. You're not isolated to the Ethereum land. You're not isolated to the features that are offered just by Ethereum. You can take advantage of the features that exist on Hedera EVM. Just to get into a little bit more at a high level of the architectural difference between Ethereum and Hedera, Ethereum has one node for everything. So basically, it handles the transactions, it handles the consensus, it handles the search for those transactions, the data, all that is living on a single monolith. Whereas on Hyro, we've got 4 different services, 4 different nodes. First one is the JSON RPC relay, which takes your Ethereum requests. Then you have the consensus node that does the actual transaction handling, consensus, execution, etc. Then you have the mirror node, where you can search for the transaction. It's a special node that we have where the data is kept, where you can answer queries really fast. And then you have the block node, which is really the block in the blockchain. There is a talk on block node right after this to talk more about that. But the advantage of having these 4 different services is you can scale them independent of each other. You can do their performance tuning independent of each other. Our network becomes more resilient. For example, an availability on mirror node is not going to impact the availability on the consensus node, where the actual transaction handling is happening. And if you're a developer who's contributing to our Hyro repos, you get a very nice abstraction of code.
During the talk, we were going into different depths of the EVM layers, but it's important to go into different topics and differences that we have within Hyro and Ethereum that are worth to explain before we go into the layers. First of all, the account model. So in Ethereum, you have one address, which means one key. And in Hyro, we have one address means one account, but one account has multiple keys. We have multi-signature keys, we have threshold keys, we have complex scheme of signatures. That's the main difference. Then the signing keys you can use to sign smart contract transactions. We support 2 different keys. Within Ethereum, you only support ECDSA key. We support ECDSA and ED25519. And also worth to mention, perhaps we are supporting a virtual mempool soon within the relay. We are not supporting a transaction pool. It's not a distributed transaction pool. We are achieving fair ordering through ABFT algorithm. It's also important to see how we are interacting with our ledger, with our with Hyro, with the different transactions we support. In Ethereum, you have the F-Send-Row transaction, which mainly is a signed transaction with an ECD key. And in Hyro, we use the JSON RPC relay for that. Then we have the special Ethereum transaction gRPC transaction within Hyro, which is an envelope, where within this envelope, we have the row Ethereum transaction. That's the construction we use within the relay to be able to manage Ethereum transactions. You can also use this Ethereum transaction via Hyro SDK. And then we have this special contract create and contract call, which allows ED keys to sign transaction within Hyro and invoking a smart contract. We also, it's worth to mention that which type of transaction we support within the Ethereum ecosystem, no? We have type 1, 2, 3, 4. Within Ethereum, we don't support, within Hyro, we don't support type 4 nowadays. We will support it soon as we upgrade to Pectra within Hyro. We are not supporting transaction type 3s because we are not supporting lobs nowadays, but we support type 1. You can either run type 1 via the Ethereum transaction, with the Sandro transaction we mentioned it before, and also we can support via the contract call and contract create, via ED keys and EC keys, type 1 transactions. And type 2 transactions are only supported through the relay, through F-Sandro transaction.
Okay. So how is Hyro offer these capabilities? Let's look at the how it compares with the Ethereum. So this is an Ethereum client. Typically, it has a consensus layer, it has an execution layer, and it has a data layer. On Hedera, we also have a consensus layer, similar to what is on Ethereum. In the execution layer, we have Besu. We are using Hyperledger Besu as our EVM interpreter. So all the Ethereum call, all the requests, they come to the Besu. Like Fer said, that we do not have a transaction pool. The consensus ABFD algorithm itself does the fair ordering of everything, so we don't need it. The data layer, we are using Merkle data structure to store all the entities, including the account states. In addition, we have a Hiro account model. What Fer was talking about, so you have the Ethereum address, you have the EVM address, you have the account, and you have multi-key. So we have a model for that, which is very unique to Hedera. Fer?
Okay, we have the EVM interpreter, and let's go to the differences within Ethereum and Hiro. So first of all, we have our representation of a block with block streams and also record streams. Of course, we translate to the outside world as an EVM block, but we have our custom blocks. We also have our custom state, which makes different the interpretation, the transaction consolidation. Also, we have system contract, we will see a little bit further in the presentation, which is the way we extend the EVM. That's the open door to the higher services. And that's
okay. So you can keep it. So let's look at how a flow looks like if you're a Web3 developer developing on Hiro platform. Let's say you, as a developer, you create a smart contract and you were able to very easily deploy it on a Hedera network. Now you want to invoke the functions in that smart contract. How can you do that? Okay. So one way is that you use the Ethereum community tools. You can use Hardhat, Remix, MetaMask. There's a whole bunch of Ethereum community tools that are available, which we all love and use. So you can use that to make that call. Let's say you want to make a transaction call. Okay. So when you make that transaction call, we have our own implementation of JSON RPC relay. That Ethereum request really goes to the relay. The relay is able to see that this is a transaction request. It will transform the Ethereum request into the format that the consensus node can handle. So it'll do that. It will send that request to the consensus node. The consensus node will do its thing. It'll execute that transaction, and then it'll respond back in the Hiro native response format. The JSON RPC relay will translate that response into the Ethereum format and give it back to you as a developer. Like if you do another transaction, which is maybe a query of some transaction, the request will go to the RPC relay. RPC relay will see that this is a query request this time, ETH call me. And instead of routing it to consensus node API, it will route it to Mayor node. Mayor node is our specialized node for searches, for any kind of transactions that you want to query. It has its own API layer. The JSON RPC relay will do that translation, give that request to the Mayor node APIs. Those APIs will respond back. RPC relay will transform that response back into the Ethereum format and give it to you as a developer. So that's one way for you to invoke your smart contracts and do queries. Another way is that you can use Hiro SDKs. We've got SDKs for all modern languages. You can pick your SDK, and the SDK will allow you to make these calls. You can do transaction calls on your smart contracts. You can make query calls. And the SDK itself will be smart enough to route those calls to the right services and give the results back to you.
Okay, as Anurag has explained, we have the transaction that change state, and we have the transaction that query state. No? Here we have another way of looking at the different layers. We can see the JSON RPC relay. When on the left hand, you have the Ethereum transaction. On the right hand, you can also have contract create and contract call, as we mentioned it, with the other SDKs or with the relay. The consensus node is attending the request with the gRPC API. The higher consensus layer is making gossip over gossip to receive the transaction and spread the information around the different consensus node, and then reaching the algorithm and ABFT to reach fair ordering. The execution layer is where we have our custom throttles, where we're doing the transaction handling, where we have the fees, and actually we are improving that, as Richard mentioned it before, with fees 2.0. And the important part we are focusing today is the higher EVM. And there we have the usual gas management, the opcodes, the precompiles, And the facades, which is one of the construction we will see in a couple of slides further, and the system contract, as we mentioned before, the door to the higher services, the count service, token service, the consensus service, and the scheduling service that we will see a little bit further. What's important to also mention is that the consensus node is storing in the MerkleDB all the state and also publishing the record stream and sidecars and the future block streams that we are going to see today in Mark's and Nana's talk. We were talking also about the transaction data querying state. We are having the relay, which is sending information and orchestrating more or less the different mirror node REST APIs I need to call to build the RPC relay Ethereum information that I need for blocks, for transactions. The mirror node is attending the REST APIs. The REST APIs are over the mirror node database, which is built in a Postgres implementation, which is reading via a stream importer all the record stream and sidecars and the new block streams from the block node that have been produced from the consensus node level. So that's overall the different layers we have seen, which is one thing that we are seeing on the slide that was very important to mention. We have the ethcall and estimation function that the usual Ethereum node does built in. In our case, we're doing that in the mirror node through a library that we expose from the consensus node to the mirror node, which allows the mirror node to simulate the transaction and give you the ethcall and the estimation, in that case, of the gas.
Okay, system contract. System contract is one of the unique things that we offer on the Hedera platform. These are really just special reserved addresses that we have where we have the Ethereum precompiles. Basically, we have written the program for you for some of the standard functionality that is needed. You can just, because they have reserved address already, if you're writing a smart contract, all you have to do is just make the call to those precompiles using that reserved address, okay? And you'll have that functionality right away. Important thing to note here is that these precompiles can change the state. Okay, so you got to be careful when you're using it. And on the next slide, you can see these are the addresses that we have. These are basically the Hedera features that you can take advantage of in your smart contract right away. The first one is 167. So 67. Anybody knows what that means? Okay, so 167 is the address for the Hedera token service, HTS. 168 is for exchange rate, so you can see what is the exchange rate HBAR to USD. There is 169, which is a pseudo-random number generator. 16A is for Hedera account service. 16B is for a Hedera schedule service, which is fairly new. So you can tell some of these precompiles will actually change the state. So you got to be careful when you're using them.
Okay, and we mentioned also what is a facade. No, there's a facade within the transaction flow. The facade is a special built-in adapter or proxy which enriches the higher entities. As soon as you can invoke a given entity with its interface. So we have here different examples what we can build on. So there's a Hedera token service facade, which allows you to invoke an HTS token address and use it as a normal RC20 using transfer from or proof. Also, you have a Hedera account service where you can call an account address and you can invoke the special features for Hedera account service like HBAR allowance or max auto associations. And also the scaling service that we will see in the next slide. You can invoke the facade and also the system contract, but in this case, you can invoke a schedule entity and sign a schedule or delete a schedule.
As you know, we are having a scavenger hunt, so
here's the next
chance
code.
to gain some points for that.
Yeah, good luck. One important thing is, after we have seen all the different layers, to summarize which are the key differences and also the benefits of using higher Hedera. No? For sure, everybody know that we have the ABFT higher consensus layer, which makes the fair ordering, the static pricing, the stable pricing, and gives you all the TPS and throughput that we are nowadays having. We have the MerkleDB that we mentioned it, where we are storing our customized Merkle tree into the database. We have the networking, gossip over gossip. We have the streams that we mentioned, the record stream, the sidecars, the block streams. That makes a difference. We have the mirror node, which is a full node within the Ethereum world, which is more queryable. It's more friendly for being able to get the information. For sure, we are extending the features via the system contracts and enhancing the EVM, as we saw with the system contracts and also with the facades. We have no mempool. We have a furthering built in. We have a special difference between Ethereum and us, which is the account model. As we mentioned before, we're supporting different keys. We have account versus a key model that we mentioned before in Ethereum. And also the different transaction layers that we have, which allows us to work on gRPC, but be able to bridge it to the Ethereum world. We usually get the questions about how we are evoluting the EVM, because we have special differences that makes us really special and make the difference and makes this evolution of the EVM and this lovely experience possible. No? When we have a new higher services implementation, we need to expose new system contracts or new function selectors within the system contracts. That's how we evolve the higher EVM in one sense. On the other hand, we upgrade our EVM with the Ethereum forks. But why we are not following Ethereum schedule? Well, we have seen the differences. So first of all, we wait until the fork is actually released, it's stable, and it gets the right adoption within Ethereum. Secondly, we investigate, research the EIPs included into a fork to actually map then which ones touch our different layers and which are meaningful for the Hedera community, for the higher community. Once we have them identified, we test them out, we implement them. We need to implement the higher improvement proposals, depending on the complexity. It's a more global HIP or it's a more detailed HIP. And then we implement it, we test it, and we roll it out. That's the reason why we are not following the schedule, and usually we are between 2 quarters or 3 quarters ahead. And as we mentioned it before, we have this system contract, which is the open door to our higher services, which make the difference. Today there's a talk that's going to talk about scaling, but I want to really open the floor with that part. It's truly awesome that you can, with Hydro, schedule a contract in the future. In Ethereum, you cannot do that. You need to rely on external providers like Gelato, like Ethereum Alarm Clock or Chainlink. And within Hydro, you can do it via a simple system contract built in. You call the system contract with the call data, with the address of the contract you want to call, with the given gas limit you want to schedule, and the network cares about all that stuff and makes the leverage of that part without needing any external provider.
Okay, so stay tuned for some of the big things coming. We are working on EVM Pectra upgrade. It should be coming out very soon on mainnet. We're working on blazing fast EVM. Richard had a moonshot goal for that, but we are continually working on improving the performance. We are working on an EVM block explorer, which will give you a very similar experience what we have in the Ethereum world. We're working on making HTS look exactly like ERC. So, you know, if you're a developer using HTS, you will be you'll have no difficulty picking it up. Delightful developer experience, we're always looking at that, what we can do to make it really sticky and very easy for the developers to pick up. And Clipper, what Richard called out as another moonshot, that's something that you'll hear quite a bit about. It's the built-in cross-chain interportability. So those are some of the big things that are coming. With that, I think we're going to stop here and take any questions if you may have. And if not, Far and I will be, oh yes, please.
I'm just, curious, so the MEE problem in Ethereum and Solana, right? That you can reorder the blocks to kind of attack other transactions and gain value, stealing value from the other transactions. What's like the core thing in Hedera that prevents that problem? And what's really like the design aspect that prevents that problem that gives you an advantage?
In Hydra and Hedera, we have the ABFT algorithm that takes care about that. It's a fair ordering, asynchronous. Nobody can intercept that or try to change the order of the transaction. You send it to the network, and asynchronously it will be built in the order. So nobody will be intercepting that. That's the main difference. We are not, as Richard meant it, so I mentioned it before, there's no leadership there to really put the transactions in order. It's an asynchronous Byzantine fault tolerant that makes it totally stable, and you're not intercepting that part. Nobody's taking care about that. It's the algorithm is taking care about the ordering.
Michael?
Yeah, it's the random number generator and the PRN, the random number generator function contract. Is that good enough if you were to use that in conjunction with KIP 1215 to, let's say, make some sort of self-recurring autonomous lottery? Would it be good enough to draw a random number, or could that be predicted in some way?
Nowadays, it's good enough.
I'll just repeat the question. So the question is, the precompile that we have for pseudo random generator, can that be used along with the HIP 1215, which is built-in scheduling for transactions? And the answer, I think the simple answer is yes. But if you want to add something more to that.
No, it's good enough. It can be improved in the randomness generation, but you can use it nowadays on the scaling service without any problem.
Like for a lottery?
For a locker.
A lottery?
A lottery, yes.
Yeah, autonomous lottery?
Yeah, as example, in our demos, in the engineering team, we are using that lottery to start who is going to start within the team. So we're using it on a daily basis, so you can use it. Piotr, you had that question?
What is the biggest challenge that here that you one challenge that you are now trying to solve? Which one is it?
Okay, so the question is, what if you were to pick one challenge on Hedera EVM, what is that one biggest challenge?
That's a good question. So I think if I need to pick one, how to extend the developer experience overall. So the ones we have been here for a long time in Ethereum. I've been here since 2017. I suffered a lot, the different tools that were there, and we're still missing a good debugging tool, the transaction, where you can trace the transaction, debug it. We have Tenderly, but something built in the IDE, or something you can really debug is something we are missing. There are a lot of things on the deployment part that can be improved. So that's what I'm thinking that's the most challenging part, which is going way further than the existing tools are. That's what I would mention. Aside the fastest EVM part, which is part of the moonshot, but if I pick one, that's my pick, the developer experience.
Okay, I think we're ready for the next talk. If you have any other questions, we're going to be hanging out here all day, so feel free to approach us.
Thank you.
Thank you.